We're in section 1.4, radical equations. So to get us started, we're going to start off with some basic vocabulary. We're going to start off with the symbol itself. This is the symbol, and that symbol is what we call a radical. Okay. Now, you notice that there is an arrow here that's pointing to a spot right here. Right now, that is what we call the index. Now, when the index is missing, such as in this case, that index is a understood 2, meaning the square root. However, if it's anything else, then it could be a different root that we're looking for, a cube root, a fourth root, a fifth root, but that index is how we tell. Then if you notice this other arrow is underneath the radical, that is what we call the radicand. And that's what we are taking the radical of, the radicand. Okay. Now, when the variable occurs underneath here, all right, that's when we get into what we call is a radical equation. Now, it's really easy to solve. It follows just our basic steps that we're used to using. So let's kind of run through this real quick. How do we solve it? Well, the first thing you do is isolate the radical. So that means that you want to get the radical by itself on one side of the equation, and you want everything else on the other side of the equation. Once we do that, we raise both sides of the equation to the power of the index. So remember, that index is that number that's sitting right here. And if for some reason that there is not a number, remember that index is a 2, meaning square root. Then we solve, and then we check our answer. Now, why is it important for us to check our answer? Whenever we're solving these, sometimes we get answers that look like they're right, and we've done all of our math correct, but they're not the correct answer, and it creates, or it's what is called as an extraneous solution. Extraneous solution. And these are solutions that appear to be correct, however, they are not. All right, so what extraneous solutions. So why is it important to check for radical equations? To make sure we do not have extraneous solutions. Okay, so let's go ahead and solve one of these, show you how easy this is. So we'll start with this one. We've got the square root of 5x minus 1 equals 3. Well, if we notice, it's already isolated. We've got the square root on one side, and we've got the number on the other side. So now all we need to do is go ahead and take both sides to the power of the index. So remember, that index is not visible to us, so we know that that index is a 2. So we are going to square both sides. So when we square both sides, what does that leave us with? 5x minus 1 equals 9. Now we want to go ahead and solve it. So we get 5x equals 10, x is 2. So it looks like everything is okay. We want to go ahead and check that answer to make sure it is not an extraneous solution. So I'm going to start by rewriting the original, which is 5x minus 1 equals 3. And I'm going to check it by plugging that x back in. So I've got the square root of 5 times 2 minus 1 equals 3. And I'm going to put a question mark right there because I'm trying to see if that actually is the correct answer. So now that I've done that, let's go ahead and solve it out. Square root of 10 minus 1, and that is square root of 9, and the square root of 9 is 3. So that is a correct answer. So we know that we are okay, that this is a good solution. So our solution set then would be 2. Now let's go ahead and check, just try the other one. If you want to go ahead and pause the video and then try it and see if you get the correct answer, that's great. So we're looking at the square root of x plus 2 equals the square root of 3x minus 5. So if you notice, both of these are isolated. I've got one radical on one side, one radical on the other side. And the majority of times when we're dealing with two radicals, that's how we want to handle this. So we're looking for that index. That index here again is 2. So I'm going to go ahead and square both sides again. And when I do that, we get x plus 2 equals 3x minus 5. And now let's go ahead and solve that. I'm going to bring that 3x to the other side, so I get negative 3x, not negative 3x, negative 2x. So let's fix that. Negative 2x equals, then we're going to subtract that 2, negative 7. So I get x is equal to negative 7 over negative 2. X is equal to 7 over 2. So we want to go ahead and try and go ahead and check this. So here we go. Square root of x plus 2 equals square root of 3x minus 5. So we're looking at 7 over 2 plus 2 equals 3 times 7 over 2 minus 5. So we do have some fractions we have to deal with here. So we're looking at 7 over 2 plus 4 over 2, which is 11 over 2. And on this side, we're looking at 21 over 2 minus 10 over 2, which is 11 over 2. So we know that this is a correct answer. Now, if you notice, I didn't actually evaluate what 11 over 2 is, and is that okay? Yeah, absolutely. Once we know that those two insides are the same, we're in good shape here. All right, so I will, you can move on to part 2 to see a little bit of a harder problem. We'll go ahead and stop this one video right here, though.